Okay, so let's begin our discussion with graphs. So the first thing which we're going to talk about is velocity time graph. But before we go to velocity time graph, I think it is important for us first to start with the basics. So I'll start with distance time graph. Okay, so I'm going to have my graph here. Let's say this is our graph. Okay, then an object or maybe a car is moving in this manner. So if this is distance time graph, meaning I have got the displacement which is going to be represented by maybe y because it is in y axis, or just d. So maybe they'll say y but in meters, meaning it is the displacement. Time they'll always put here t in seconds. Now let's say this is point O, this is point A, this is point B, and this is point C. And we are assuming that time here it is 2, then there it is 4, here it is 6, there it is 8, and here it is 10. Talking about time there. So we can clearly see that this time here it is straight on 4. This one I want it to be straight on 6. Okay? Meaning that here I can put, I'm going to put now numbers here. 1, 2, 3. So I'm going to put 10, I'm going to put 20, I'm going to put 30. Okay. The first question they're going to ask you is find the velocity at t is equal to 4 seconds. So when time was 4 seconds, what is the velocity? So you know that velocity is given by the change in displacement. So in this case we're talking about y, so I'll say the change in y divided by the change in t. That is the velocity. I'm using displacement on top because last time we agreed that the velocity, when we're talking about the velocity, velocity is a vector quantity. So velocity goes with displacement. Speed goes with the distance. Okay? Meaning, if I want here, I can do this. Okay? So the change in y is basically y final minus y initial. So when I start from the first stop here, that is my y initial, which is 0. This point. At A, that's where now we're talking about when t is equal to 4. When t is equal to 4, it is there at A. So at A, the distance is 30. Then it's going to be 30 minus 0, which is just 30. So in this case, my velocity is going to be 30 divided by 30 divided by 4. I don't have a calculator nearby. Okay, I have it. So it is 30 divided by 4. I'm getting 7.5 meters per second. That is my velocity. That is the same thing. They can also ask me to find the speed between A and B. I'll do the same. So in this case, it was not changing, it was constant. The distance was just constant. It's more like this person was now resting from point A to B. This person was trying to eat something. Okay? It's more like you are coming from Lusaka, you go to Kabwe, you are going to Murungushi, then you rest within Kabwe before you reach Murungushi. So now, as you are resting there, what is happening is the time is going, because you might reach there in Kabwe 12 hours. You might waited, maybe you want to wait for about maybe 30 minutes. Time is going, but the distance is not going. It's not moving. So you are not moving, the distance is constant, it is still at 30 meters. Then it's going to be 30 minus 30 divided by time. So time is moving from 4 to 8, which is again 4. 8 minus 4 is 4. So it will be 0 over 4. So the speed there is 0 meters per second, because this person was not moving from point A to B. Okay, that is making sense. Same applies to B to C. So B to C, this person now is more like this person want to go to Mulungushi, but after reaching Kabwe, you have rested for about 30 minutes. And then you are like, no, I've changed my mind. I think I'm not going to do my studies from Mulungushi. I'm going back to Lusaka. So this person from B to C is going back to Lusaka. So going back to Lusaka, you are going where you are coming from. So it's basically the same thing. The final now, it is at this line, which is 0. So the final is 0. The initial is, you started from Kabwe, which is B, 30, divided by time. Time now, B to C, it is from 8 to 10. So 10 minus 8 is 2. So you end up having negative 30 divided by 2. So the velocity now at that point, since you are coming back, it is negative 15 meters per second. That's the basic idea behind the distance time graph. It is something that is very simple and straightforward. It's just a matter of you know, when it comes for these graphs are not something which is hard. If you know the SI units for the thing which you want to find, it becomes easy. From here I can clearly say that the displacement is in meters. If I divide it by time, perhaps I'm going to have meters per second. Meters per second is velocity. That's why when finding velocity, we are saying the distance divided by time. Okay. Now let's talk a bit of velocity time graph. Velocity time graph. So how do you tend to find, because under velocity time graph there are few things which you need to be familiar with: how to find the acceleration, how to find the distance. Yeah, those are the main things. Yeah. So now let's go ahead and start. I'm going to teach velocity time graph using this question, where we have A, point 0, A, B, and C. Now, I'm going to go direct to how do you find the acceleration? So acceleration is given by V final minus V initial divided by time. Time, it is basically the same as, also you can say T final minus T initial. It's okay. That is how we are going to find the acceleration. Now, why are we saying this formula is valid? Because velocity is in meters per second, time is also in seconds. So it's like you have got meters divided by second divided by, again, second. So meters divided by second times 1 over second. So you are going to have meters per second squared. That's the reason why we use this formula when we're talking about the graph. Okay. Yeah. Now another thing which I want you guys to be familiar with here is this: how do we tend to find the displacement? Now, the displacement in this case, we're talking about distance. Distance and the displacement, I explained the difference. So let me just say distance. I'll be using distance. So distance, we know that it is in meters. Now under graph, I need to find a way on how I'm going to find the formula which is going to help me to have what? Meters. Okay, now let's go back. If we have got a triangle, if I want to find the area, let me start with the rectangle. Yes, let me start with the rectangle. If I have got my rectangle, which is like this, I'm going to assume that this is L, this is B. So it is L times B. But here now, we are assuming that L, it is meters per second. So let's put there. Meters per second times breadth, it is in seconds, which is this line. Okay, that line, it is for breadth. Let me do this. So I'll put length as the seconds, then breadth to be meters per second. Meters per second is basically the same as m divided by s. So s and s can go, and I'll remain with just m. Meaning that whenever I want to find the distance, if I've been given distance time graph, sorry, the velocity time graph, as long as I'm going to get the area of that shape, then that is my distance covered by that object at that particular time. Okay, what do I mean? So if I have got a triangle, let's say we have something like this. Okay, so we know that this is L, this is so the formula for triangle, we say area is given by half BH, where H, I'm going to say this is B and this is H. H is the height. So now if I check properly here, the first question here is saying calculate from the graph the total distance traveled. They want the distance from point O to A, from point O all the way to C. Now here it's just a matter of you knowing the shapes which we have here. So we have got the shape, there is this shape here, and the time is just in between 10 and 20, which is 15. There is also this shape here. Okay, that one, which the time is exact at 40. So now that I'm going to be using different colors. Now this one is one triangle. That triangle, let's call it 1. Then I have got rectangle, which is here. I'll call it area 2. So I'll put 2 there. Then I have another one, which is this part here. I'll call that one as 3. Meaning that if I find area 1 plus area 2 plus area 3, that is going to be the total distance traveled by this car. Wow. Now, how do we find the area? So area 1 is basically the triangle. So triangle is always half BH. Okay? So plus, what is area 2? Area 2 is basically L times B. Then area 3 is also a triangle, half BH. So if I start plugging in the values here, we can clearly see that I'll have half. Okay, my breadth here is from 0 all the way to this point here, which is 15. Okay, so that is 15. Then what is my h? My h is this line reaching that point where there is a, which is 50, plus my l. Now in this case, I'll say it is from 15 all the way to 40. So you say 40 minus 15, that is 25. So 25 times, what is the breadth, which is now going here, reaching at A or at B, is the same thing, times 50, plus again half. Breadth from this point here all the way to 50 is 10. Then height is the same thing, 50. To make things simple, 2 there 1, 2 there 25, 2 here 1, 2 here 5. So what we have is 15 times 25. So I'm getting 375 plus 50 times 25. I'm getting 1250 plus 5 times 50. I'm getting 250. So if we are to add here, the total area now will be equal to 250 plus 1250 plus 375. So I'm getting 1875 meters. That is the total distance. Okay, that is the total distance. Now if I go to part B, which is saying what distance does the car travel between time, now it's between time when t is equal to 10 and t is equal to 40. Allow me to get rid of this again so that we look at it clearly. Okay, I look clearly. Okay, so there we go. This is what I'm going to do. We have got t when t was equal to 10 is here, and when t was equal to 40 is there. Now the problem comes in. Now we need to talk about the shapes now. What shape is this? So it's like I have got this shape which is going like that, like that, like that. So that is the shape. Believe me, the best way to resolve this one, I can make what we call trapezium. Trapezium, it is in a form of this. That is what we call trapezium shape. Now trapezium, you are going to have the height, the length, and also there is also what we call the air. So there is the moment you see, I can clearly see that the shape which I've just drawn here is basically the same as this shape. If I can put it clearly, where is it? So here is supposed to come like that. Let me just give you a basic yeah, so I can say that is the basic idea behind trapezium. Now when you have got this kind of a shape, now how do you find like the formula for trapezium? So the formula for trapezium, to find the area, it is given by half. Okay, am I going to remember this formula? It is given by half a plus b times h, of which h is the one I've given you. Then this is a and this is b. Okay, so that is the formula for trapezium. So what is happening here now is this. When you see a simple shape, when you see a simple shape like the one I've just drawn here, that is trapezium. So if I check here between 10, I think the best way which we can do is between 10 here, this is 10, now it ends there, that is 10. If I want, I can find, yeah, if I want, I can find this. If I want, I can go ahead and find that. Then it goes there, and also where there is 10, meaning I've got that ka shape. So there are so many ways of killing a rat. There's that a shape. There is also a small one, don't forget, of which I can say this one also makes a trapezium, which is going like that. I'm failing to draw a proper one here. That one. Yeah, so that one gives me a trapezium again. But again, I have also another shape, which is this shape here on top. That shape, it goes there. But again, that shape, if we look at it clearly, I can clearly see that if I just cut there, it is another trapezium this side, and again there will be a triangle here. So it's more like I've got this is a shape, that's a shape, and this is again a shape. Okay? If I want, I can use a different one. So it's just a matter of you knowing which shape is going to be easy for you. Okay? So we're talking about 10. Again, if I want, I can use a different one. I can say from this point here, it comes there. Let me use a straight line. I'll use this one. Let me use red. This one, it goes all the way to what? To 40. Okay? Then, if I reach at 40 here, it will come like that. Then here, if I go straight, it will come like that. Then there, it will come like that. That is the shape I have. Now, at the same time, this shape, I can divide it again into two. I can get this gamma shape here to be more like a trapezium. That shape. You can, in fact, this is going to be easy for us. There is this small shape here, is going to be trapezium, same as the one I've just drawn here. Same as this one. But we are talking about this shape here. That is trapezium. Then the remaining one, it is what? This is a rectangle. So how can I'll start with the trapezium. So that trapezium, this point here is A. Let me do this. This is A. Then that is B, that side. And that is H. That side is H. So if I use this formula to find that trapezium, it's going to be half. My A is from 0 here all the way to that point, which is 30. That is my A. Then my B is from this point all the way to where A is, which is 50. What is my H? My H is the distance between from this point all the way reaching that point, which is just from 10 to 15, which is 5. Okay? So it will be half. Inside there it will be 80 times 5. 2 there 1, 2 there 40. So 5 times 40, which is 200. So the area of the trapezium, I'll say area 1 is 200. 200, we're saying 40 times 5. Yes, it's 200 meters. That's area 1. So it's meter squared, but since I know that area is the same as I'm getting the distance in that case. So I'll just say meters because it's that distance. Then now let's talk about the area for the rectangle, which I have there. So rectangle is always L times B. So L times B. So L in this case, you can just get anything from 15 all the way to 40, sorry. So it is 40 minus 15, which is 25. So you have 25 plus. From this point all the way to that point, it is 50. Or times 50, not plus. So it's 25 times 50, which is 1,250. So you are going to add that one. So you are going to say 1,000 1250 plus 200, meaning that the distance between t, when t is equal to 10 and t is equal to 40, it is that one plus 200, 1400 meters. That is the distance between when t was equal to 10 and when t was equal to 40. As simple as that. Does that make sense? Now, if I go to part C, which is saying draw a graph of its acceleration versus time. Okay, acceleration versus time between 0 to when time was equal to 15. So here, for us to find the to have the graph of acceleration versus time, to find acceleration, like we said, you just do this. Acceleration is v final minus v initial divided by time. So time is also t final minus t initial. Let me put it that way for the graph. I'll say t final minus t initial. So we have been given here, how many journey do we have? We have 3 journey. Okay, we have 3 journey. So the first journey we have from 0 or from O to A, or from 0 to A. I need to find the acceleration there. So I'll say the final is at that point, which is 50. It started from 0, so the initial is 0, divided by time. What was the time at A? At A, exactly the time was 15. So A will be equal to, okay, that is, allow me to say from O, to make things simple. A, which is from O to A. What is the acceleration from O to A? So it is 50. I divide it by 15, which is 3.3 meters per second squared. Okay. Then what of the acceleration from A to B? So again, I'll use the same one. I'll use the same formula. I'll say acceleration is equal to the first velocity, the final velocity here, it is at B, which is 50. The initial started from 50 again. So initially, if it is constant, like I said, it's going to be 0. Acceleration from A to B is 0 meters per second squared. Then what of acceleration from B to C? We expect it to be negative because it was decelerating. Acceleration from, so it's going to be what? Okay. The final acceleration is 0 here at this line. 0. The initial started from 50. I divide time. So time from this point all the way to 50 is just 50 minus 40, which is 10. So it's going to be 5. So acceleration from B, all the way to C, it is negative 5 meters per second squared. So how do we draw the graph? Okay, how do we draw a graph? So I'm going to have my graph this side. do this. That graph is going to be like this. Let me put it like that. It will be like that. Remember, the time is the same. So let's come up with the scale. So we are going to say this is going to start from, this is 0, meaning if this, can I have 2? Should I write 2 and 4? Or I can write here 2, then here let me put 4. Meaning 3 is in between. Meaning that graph, the time, let's just be genuine here. The time when we find that it was -3, what was the time? What time did we plug in? When we found it was, the time we found was 15. Meaning that I'm going to have 15 here. Let's put our time to be 15. Okay? What else? Another time when it was constant, what was the time? From A to B. So A is 15, B is 40. What is 40 minus 15? 40 minus 15. That is 25. So I'm going to put, so I'll say is 15. Meaning I'll come back here and put 25 or 40 because it was 40 now. Then now what happens? From B to, that is 50. So I'll put here 50. But you know what I'm trying to do here is, you can still put the same 0. From 0 then you put 10, 20. It's the same thing. In fact, that would be even better because time we're not supposed to change. Let's just put the same thing. We just say 10, 20, 30, meaning that will be 40. Let's put 50 here. Okay, that will be easy now for us. Let me just get rid of that part. So when it comes to acceleration, the graph is a bit different. So here I'll go further and say this is -2. I use visible color. This is -2, then this is -4. Then I'll go further and say this is -6. Okay, so it is starting from 3. Starting from 3, but it goes there all the way to what? The time is 15. That time when we found 3.3. So 3.3, where can we find? 3 is in between. 3.3 just on top there. So the time is 15. So let's say the time 15 is there, meaning it will come there straight, then it goes there. From there now, it was constant up to where 40 is. So from here, it was constant up to where there is 40. You end there. What else? From 40 to 50, what was the acceleration? -5. So it has to come there. You come straight. -5 is between -4 and 6. I'll say is that point. So it will come that point. Now it has come at that point, but we know that when it reaches that point, it has to rest. Then it will go back to that 0 because this one came back to 0. So this graph is basically exactly as this graph. I hope you have gotten the logic there. Okay. So if you want to access full tutorial sheet videos, you just go on our website. You type Transcended Institute, and then you'll be able to see this website. So if you want maybe math, or let's say you want physics, you click on physics. So physics, here we have got all the topics for semester 1 and semester 2. So what happens is that if you want maybe to learn kinematics, you come here. There is a topic, linear motion, which is kinematics. You'll be able to find the videos. Okay, projectile motion, you'll be able to find, these are detailed videos. When you watch these videos, you'll be able to understand more on this topic. So now what is happening here is, if you scroll down here, you'll be able to see that there's physics 101 tutorial sheet. You click here, you'll be able to find the solutions for the tutorial sheet 1, tutorial sheet 2, 3, as well as 4. So this is where you can now access full tutorial sheet videos. So register with Transcended Institute, then you'll be able to access all the topics as well as the full topics videos. So in case you want to register with us, just search on Google Transcended Institute, and then you're going to see the website. You use the same website, you can pay using the site. If you're going to have challenges, it's okay, you can inbox me if you have my number. If you don't have my number is 0767 729927. 0767 729927. Thank you for watching this video.